got it. And what?
Can people hear me? Just let me know if you can hear me, maybe in the chat. Right. Ah, perfect. Right. It's nice to see faces. I don't know if it's an accident, Grace. I can see you. So probably the first time ever I can see a student. But it's really nice to actually see someone. Okay, so today we are going to do some maths. So I've got 8 problems for you prepared. So I have this is the whiteboard I'm going to use. You can see, you can skim through it, and okay, we'll start in 2 minutes. Okay, can you please keep yourself muted if you're not? Right.
Recording in.
Okay, Talia and Malan, can you mute your mics, please?
Oh shit!
Okay. Ah, I've got a gallery view. Okay. Speaker view. Oh. Okay. You should see me now. Right. So I will start. And just before I start, can you do a task? So I would like you to reply with 2 numbers. And the first number would be the difficulty of maths. And the second number is difficulty of physics on a scale of 1 to 10. Yeah. So if I found both incredibly difficult, I would put 10, space 10. So maths, the first number, and physics. So please reply in the chat how difficult out of 10 you found the 2 assignments. 5, 8. Okay. 5, 9. Okay. 1, 7. So not difficult at all. 3, 5. 7, 6. Somebody's not muted. Can you please mute yourselves?
Muri.
Okay. Right. So let's have a look at the chat. Okay, 6, 6, and 8. Okay. Right. Okay. Thank you. I got a span. That's nice. Okay, so I'll share my screen and go through some questions. And sure. So okay. The first question. Find the vertex of a parabola by completing the square. Find the vertex of a parabola by completing the square. There are different ways you can find the vertex of a parabola. But in the assignment, you have a problem. You have a very similar problem where you need to find the vertex of a parabola of the general parabola. So is where you need to find the parabola ax squared plus bx plus c. Here you have this parabola, and you need to find its vertex by completing the square. This is a somewhat similar task. You can see that there's a b here, so there's a parameter. Just quit stuff I don't need. Okay. So let's start. So when I complete the square, the first thing I do, I take the leading coefficient out of the brackets. X squared minus, now this is going to be b over 5 and plus 3/5 plus 3/5. Okay, then I continue. So open brackets. To complete the square, well, there's a formula to complete the square, and the formula looks like this. X squared plus bx plus c is x plus or minus b over 2 squared minus b squared over 4 plus c. You can use the formula if it's or you can just use well, common sense. There's an x here, and so if the second coefficient is that, so we divide this by 2 and square it. That's what's missing from the completed square. So if you don't know how to complete the square, it's not the end of the world, but do learn that. That's incredibly important. So plus it's going to be b squared over 100 minus b squared over 100 plus 3/5. 3/5 and we have 5 square bracket. Now this is a completed square. This is x minus b over 10, x b over 10 squared minus b squared over 100 plus 3/5. And then you open the brackets. So you get 5, open bracket, x minus b over 10 squared minus b squared over 20 plus 3. And now you look at this expression. You look at this expression again, you see that this thing is a constant. This is a constant. It does not depend on x. And this thing is greater or equal to 0. So the smallest possible value it can take is 0. So it could be 0 or less. It could be 0 or less, and 0 or more. And therefore, the smallest value of this expression is this. Smallest value. Therefore, you have the parabola, which has a vertex at the minimum position. The minimum position is when x is b over 10. So y let's rewrite this. 5x minus b over 10 squared minus b squared over 20 plus 3. And y is minimum when x is b over 10, because this is when this part of the expression is 0. So this has to be 0. So b over 10 is the x coordinate of the vertex. And then if we substitute b over 10 here, this becomes 0, and y becomes minus b squared over 10 plus 3. Okay, and this is the answer. Now, in the assignment, you will see problems that contain, apart from x, contain another letter. That means you need to give your answer in terms of in terms of that letter. So, for example, if the question contains a, you need to give your answer in terms of a. Okay. So an example would be like this. So solve the equation, solve x squared minus a squared equals 0. That's a quadratic equation. And you would find x. So in this case, use factorize x minus a, x plus a equals 0. So x, the first solution is a, the second solution is minus a. So this is a valid method of solving. So you give your answer in terms of a. So if you see something like that, or any equation containing x and a, that means you solve for x in terms of a. Hope that makes sense. Right. So moving on to problem 2. So we have a parabola, and they say x equals 3 is the line of symmetry. So let's just verify that. And this is a very powerful tool. Let's just verify this using a graphing calculator. So we have y is x squared minus 6x minus 7. Y is x squared minus 6x minus 7. So that's a parabola. Nice. And then we have x equals 3. And it does indeed look like x equals 3 is this line of symmetry. So yeah, I mean, so that simply just says it's not a random question to ask. Okay, so we've established that. But how do we actually prove it? How do we prove that something is a line of symmetry? Well, let's go here and say you have a graph, and let's say you have a line of symmetry, and you have a graph. Let's say the graph looks like this. So you need to prove that x equals a, this one, is the line of symmetry for this graph. And this graph is f of x. F of x. Well, if you go, if you step, so if this point is a, so let's make a small step to the right. And this point is going to be a plus x. So we've made a small step, a small x-sized step to the right. And now let's make an identical, sorry, I didn't mean to ask to unmute you. That's not what I meant. I wanted to mute you. So if you received a message, please unmute, don't. I'm making a small step to the left, and this is going to be a minus x. That's a small step to the left. And here we are. Here we are. And we know that they have to be identical because there's a line of symmetry. These values have to be the same. In other words, f of a minus x has to be equal f of a plus x. Okay. Do you understand this diagram and this conclusion? Please let me know in the chat. Yes. Okay. If you don't, let me know as well. That's very important. If you don't, if there's something you don't understand. Okay, brilliant. I love to see a lot of activity. So brilliant. And that's the thing. So x equals a is a line of symmetry. Symmetry if this is true, and that's what we're going to use. So if solution if x equals 3 is a line of symmetry, f of 3 plus x has to equal f of 3 minus x. Okay, let's find f of 3 plus x. So all we do is we substitute 3 plus x instead of x. So it's going to be x plus 3 squared minus 6, open bracket, x, or 3 plus x. Well, it doesn't really matter, but 3 plus x, 6, 3 plus x, minus 7 equals 9. So you open the brackets, plus 6x plus x squared minus 18 minus 6x minus 7. And this simplifies too. So 6x and 6x cancels. X squared plus 9 minus 18 minus 7. X squared minus 16. We can also prove that x is the line of symmetry, but by taking the x ordinate of the vertex. That is if you know the properties of a parabola, yes. But look, one of the questions in the assignment that you need to prove that x equals minus b over 2a is the line of symmetry. And you kind of need to prove it without the knowledge of that this is a parabola and the parabola has the following properties. That's not how it works. You need to prove that for this function, this is a line of symmetry. So from the ground up. Because what is your argument? You're saying it is a parabola and a parabola has a line of symmetry, but that's what you need to prove. So you can't use that. Would it not be 3 plus 3 squared as x3? No, it's not x equals 3. X is not equal to 3. Instead of x, we put 3 plus x. Okay. X squared plus minus 16. And now we find f of 3 minus x, f of 3 minus x, and we should, if x equals 3 is in fact a line of symmetry, we should get an identical expression. So 3 minus x squared minus 6, 3 minus x minus 7, we expand 9 minus 6x plus x squared minus 18 plus 6x minus 7. So minus 6x and 6x goes away, x squared. So we're left with x squared and 9 minus 18 is minus 9 minus 7 is minus 16. So they are identical. So f of 3 plus x. So if from 3 you make a step to the right, it's the same as from 3 you make a step to the left, 3 minus x. And that is, maybe if it would be easier if we, yeah, well, it would be easier to use a different letter for x. Maybe that would be less confusing. But the idea is you're making a step to the right, you're making a step to the left, and you're comparing the result, and the results are identical. Therefore, x equals 3. Lucky Sanan, that's what I was explaining previously. You need to prove that a parabola has a line of symmetry. So you can't use the fact that the parabola has a line of symmetry to prove that the parabola has a line of symmetry. Okay? So for this particular question, you could say, we know what a parabola is. We have proved that a parabola has a line of symmetry, and this particular parabola has a line of symmetry at x equals 3. But in the assignment, you have a general question. You need to prove that a parabola has a line of symmetry. And this is the way to go. And this is the way to do it. I'm sure there are, I could think of several other ways of doing it. But if you ever encounter a similar problem, well, you kind of know what to do. You know what symmetry is. And this applies not only to parabolas, this applies to any function. So it could be a, yeah, you can use this to prove that any function has a line of symmetry, or at least to test. Therefore, x equals 3 is a line of symmetry. A line of symmetry. Yeah, I'm sure you know. I'm sure you know how to find the vertex of a parabola, and I'm sure that you can make a conclusion that the vertex is there's a line of symmetry going through the vertex, but that's not what we're trying to teach you here. If that makes sense. You got me here. Well, you could complete the square and say that this expression does not change if you Yeah, I mean, there aren't any like quick and elegant ways, but yeah, one of them is differentiation. Absolutely. You can transform the graph and then see that the transformed version has a line of symmetry at x equals 0. I know I said before that there are many other ways, but I mean, I can't see like elegant ways right now to do it in any other way. Yeah, I mean, this is the simplest general method. Of course, for any parabola, you can apply the properties of a parabola. You can say, well, it's a parabola, and this is what we know about parabolas. But if you're talking about any kind of graph, like for example, this y is x to the power 4 plus 3x squared plus 2. If you want to prove that this graph has a line of symmetry, you need to use this method. And the line of symmetry would be x equals 0 in this particular case. X equals 0 is a line of symmetry. But this is an incredibly easier example because this is an even function. This is an even function, and all even functions have x equals 0 as a line of symmetry. Something you do when you study even and odd functions. Okay, problem 3. Problem 3. You have a parabola that passes through 3 given points. Find the values of a, b, and c. And this is kind of a an even function. Okay, an even function is even. F of x is even. So this is a definition. Is even if f of minus x equals f of x. So example, what f of x equals cosine x is even. Yeah, that's a formal definition. Cosine x, because cosine of, if you take a calculator and you do cosine minus 10, it will be the same as cosine 10. And this is true for any number. Cosine minus x is equal to cosine x. You will see that cosine is an even function. Okay. There's something a little bit more fundamental in this question. If I give you 2 points, there's exactly one line that you can draw through 2 points. If I give you 1 point, there's infinitely many lines you can draw. But if I give you 2 points, there's exactly one straight line you could draw through 2 points. And that's one of the fundamentals of geometry. If I give you 3 points, any 3 points, which are not on the same line, there is exactly one parabola you can draw through 3 given points. So you cannot draw 2 different parabolas through a set of 3 points. And this is a bit of a fundamental here. That means if you have 3 points which are not on a straight line, there's exactly one set of value of a, b, and c values that would satisfy this. And if you take a cubic function, like ax cubed plus bx squared plus cx plus d, you need 4 points. And if you have 4 points, there's exactly one cubic expression that goes through exactly through 4 points. Okay. And so on. It works for higher powers as well. So for a polynomial of the 6th power, you need exactly 7 points. And it doesn't matter. You could have 3 points like this. There's still exactly one parabola that goes through 3 points like this. Okay, so that is fundamental, and you'll have some sort of similar task in the assignment. Oh no, I changed that. It's slightly different, anyways, but that's a thing to bear in mind. That's the thing to bear in mind. So if I give you 2 points and ask you to find a parabola going through 2 points, you need to understand that there is infinitely many parabolas going through 2 points. Because if you have only 2 points, the parabola can go like this. The parabola can go like this. The parabola can go like this. There's infinitely many parabolas going through 2 points. But with 3 points, there's only one. Okay, and to find these, this is just there are no magic ways of doing it. It's just simultaneous equations, and there is a fundamental. Well, there is a conjecture that if a problem cannot be written as simultaneous equations, that means the problem is unsolvable. I don't know if it has been proved, but it's certainly true for any problem that I have ever encountered in my life. And okay, so you have, we'll write the expression like this: plus bx plus c equals y. This is the original formula. And all I need to do now is substitute all these values into it. So for the first point, x equals 10, y equals 18. So it's going to be 100 times a plus 10b plus c equals minus 18. And we will call this equation 1. The second point is 6 minus 22. So x is 6, so that's 36a plus 6b plus c equals minus 22. And we will call this equation 2. And the third one is 14. So 14 squared is 196. A plus 14b plus c equals 2. And we will call this equation 3. Now, these simultaneous equations may look scary, but actually, well, you kind of need to start eliminating. You need to start eliminating. First, you eliminate C, and then you eliminate one of the others. So what I'm going to do here, we're going to take equation 1 and subtract equation 2. And from equation 1, it's going to be 64a plus 4b equals minus 18 minus 22, 4. And I can divide by 4. 16a plus b equals 1. And I'm going to give this equation a name, so I'm going to call it equation 4, because I might need to use it in the future. And this is a very scientific way of doing it. So if you adopt this method, this is what scientists do. Then you take equation 3 and subtract equation 2. Subtract equation 2. So it's 196 minus 36. That's 160. A. 14b minus 6b. So that's plus 8a plus 8b. C minus c is 0. And 2 minus 22 is 24. And as usual, you could divide this by 8. So that's 20a plus 20a plus b equals 3. And we won't give this equation a name. This would be equation 5. And now I do equation 5 minus equation 4. Minus equation 4. And 20 minus 16, that's 4a. B minus b is 0 equals 2. So a is a half. So from here, I can find b. B is 1 minus 16a. So this is from equation 4. So equation 4, 16a, and that's equal to 1 minus 8 equals minus 7. So we found b. And to find c, we just choose any equation, actually. So I mean, I'm sure you can solve simultaneous equations. I'm just showing you more. I'm more interested in showing you the notation and my way of thinking when I try to do it. When I try to solve simultaneous equations. So I'm sure if I give you these three equations, you won't be able to do them. Question is, how many steps are you going to make? Okay. You can use a calculator to test yourself, yes, but you need to show your work. Yeah, you need to show how you got there. Okay, but I'm happy for you to check your answer with the calculator. But you need to show how you got there. You need to be able to do it without one. So and then you find C. Well, C. I won't bore you with the details. C is 2. And we found the parabola. We found the parabola. We found A, B, and C. So Y is, so the answer Y equals a half x squared minus 7x plus 2. Equation 4. We're dividing by 4. Oh. Okay. Yeah. Oh, Anthony, you could do it any way you like. Yeah, it doesn't have to be in this particular order. This is just one of the ways. There are plenty. You can use Cramer's rule here. I mean, with matrices, like you can do 100, 10, 1, 36, 6, 1, 196, 14, C, 14, 1, and multiplied by XYZ, multiplied by XYZ. This is matrix notation. You're going to study matrices further on, but 22, 2, and to find XYZ, all you need to do is take the inverse of this matrix. So 100, 10, 1, 36, 6, 1, 196, 14, 1. Take the inverse of this matrix and multiply it by minus 18, minus 22, 2. And if you have a fancy calculator, one of those Casio, what are they? Well, any Casio calculator actually will do, and you can find that. Okay, moving on. Solve the equation for x in your head using Vieta's formulae. Okay, Vieta's formula is something you don't study in school, but I think it's an incredibly useful tool if you know how to use it properly. So let's say you have a simple equation, x squared minus 5x plus 6 equals 0. So normally you would factorize it. Yeah, you would factorize it and say it's x minus 2, x minus 3, and that is, so x is 2 and x is 3. Okay. There is a slightly different way of doing it. You could use Vieta's formula. Vieta's formula is that you find the product of the two, the product of the x's is c divided by a, and the sum of the x's is minus b divided by a. So in this case, c divided by a is 6 over 1, so that's 6. And minus b, so minus 5 over 1 is 5. So all you need to do is simply two numbers that multiply to 6 and add to 5. So x1 is 2, x2 is 3. So when I say solve an equation in your head, this is what I mean. Solve an equation in your head. This is what I mean. And sometimes you get like really nasty ones. So let's say you have 103 x squared plus ew, 103 x squared plus 98 minus 201. Does that work? Yeah, that works. Equals 0. Now, you'd be very surprised if I tell you that you can solve this in your head. Yeah, x1 double negative. So this is slightly different from what you're used to. You're used to factorizing. We're not doing factorization here. Yeah, please keep that in mind. And having said that, this can get you confused. But you need to understand this is a slightly different method from the factorization. So if you're used to factorization, this might get you confused, but Hopefully it doesn't. It's interesting that in some countries they teach this method, but they don't teach the factorization method. So what I do is I teach them the factorization method, and they get confused. So just be aware. So you can solve this in your head using Vieta's formulae. When in your head means without using the discriminant, without using the formula or without using the calculator. That's what I mean by in your head. So what you do, write it out regardless. So x1, x2 is minus 201, 100 and the product, the sum, x2, is minus 98, 100 thirds. So you need to find two numbers that multiply to 201 100 and add to 98 100. Now the denominator looks like a prime number, so it looks like it's going to be two numbers, and the denominator is going to be 103 in the first case, and it's going to be 1 in the other case. And the product is 201. So how about that? 201 and 1. And one of them goes with a minus. Oh, look at that. It works. It actually does work. Because you need a product which is 201 and 201. Well, 201 and 1. And the denominator is 103. And look at that. So this is x1, this is x2. And let's check it. x1 times x2 is going to be minus 201, 103. And x1 plus x2 is going to be minus 201 plus 100 minus 201, 103. Plus 103, which is minus 98 100 Ta-da! So you found the solution, which is 1. This is the answer. So this is just another arrow to your bow. Yeah, another arrow to your, not the bow, the other thing where you keep the arrows. It's just another tool to solve. So let's have a look at this one. So you have two numbers. So you use the Vieta's formulae, x1, x2. The product is minus 3a squared over 7. And x1 plus x2 is going to be 4a over 7. Okay. So when you add them, it gives you 4a over 7. And when you multiply them, it's minus 3a squared over 7. Any suggestions what x1 and x2 can be? Like, even don't worry about the signs. Something over 7 and something over 1. True. Something over 7 and something over 1. Now the product is a squared, but the sum is a. Yeah. So so 3a and a or maybe it's the other way around. So we can check, all scenarios. We can check a over 7 and 3a over 1. That's another possibility. So let's keep checking. So the product is negative. So one of them has to be negative, and the sum is positive. So that means the bigger one has to be positive. And a over 1 is bigger than 3a over 7. So this one is positive, this one's negative. Let's test it. So x1, x2, so 3a squared over 7, that works. And 4a over 7, so that's 7a over 7 minus 3 over, oh, it works. So we don't need, we don't care about this bit. That's it. So this is x1. So x1 is minus 3a over 7. And x2 is a. So solving spontaneous equations. Oh, sorry, solving quadratic equations in your head, which is, yeah, which is great. Like, but I do have a confession. I was taught this in school, and I did not find it appealing. I did not like it at all, and I never used it until well, actually, when I was at university, or even later. I always used the formula. I always used x1, maybe because I was quick at doing it, plus minus square root of b squared minus 4ac divided by 2a. And even when I did factorizing, I did factorizing in a slightly different way. So what I did is, so ax squared plus bx plus c can be factorized like this: a x minus x1, x minus x2. So if I wanted to factorize something, even something very easy, I did this, and then I used this formula. Cubics, yes, it's just, yeah, it's a bit more, for cubics, you have 3 expressions, and you can look it up. So you have x1, x2, x3, because there are 3 solutions, 3 equations. And I think this one is minus c over a, x1, x2 plus x2, x3 plus x1, x3. And this would be something like b over a. I might be mistaken with the signs, but there is x1 plus x2 plus x3, which is another thing, probably. Oh, not C, sorry, D, because there are 4. There's C and this is B. So don't quote me on this, but there is the same for cubics. Okay, so something over something, there's something over something, and there's something over something. Okay, this you can quote. not that it's very useful. Okay, problem 5. Problem 5, without solving the equation, find that. And when I say without solving the equation, I kind of mean it, because if you try to solve it, x1 is going to be 7 plus or minus square root of plus minus 7 plus minus square root of b squared, so 49 square root of 49 minus minus 4ac, so minus 12. So that's divided by 2a, which is 6. So that is 7 plus minus square root of 49 minus 12, that's 37. 37 divided by 6. So good luck finding the fourth power of this without a calculator. Yeah, if you have ever done anything like that, you understand that it is a pain. This is incredibly difficult to find the fourth power of this. Possible, yeah, but not easy, not an easy thing to do. So not that it is, I want you to do it this way. It's very impractical to do it this way. So what I'm going to do here? Well, I'm going to use Vieta's formulae. So first, I know that x1, x2 is going to be c over a, which is a third. Then x1 plus x2 is going to be minus b over a. So it's minus 7 over 3. So that's 7 over 3. That's the first thing. Secondly, I want to find x1 plus x2 squared. Well, obviously it's going to be 49 over 9, but I'm going to do it differently. I'm going to be x1 squared plus 2x1 x2 plus x2 squared. And from here, I'm going to find x1 squared plus x2 squared, which is in fact x1 plus x2 squared minus 2x1 x2. And from here, I can actually calculate that. Plus x2 squared is going to be x1 plus x2, which is 7/3. So 7/3 squared minus 2 times a third. So 2/3. So 49 ninths minus 2/3. So 49, so that's 6 ninths. So 49 minus 6, that's 43. 43 ninths. Yes, I did not make a mistake here. Good. And this, we've been doing this in preparation for the main event. x1 plus x2 to the power 4. x1 plus x2 to the power of 4. And we use the binomial formula for this. If you don't know the binomial formula, don't worry. All you need to do is do 4 brackets and just expand them. Yeah, so x1 plus x2, x1 plus x2, x1 plus x2, x1 plus x2. It's not the fastest thing to do, but it's doable. Yeah, and do it. If you don't know the binomial formula, do give it a go and do test it. So it is x1 to the power 4 plus 4x1 to the power 3 x2 plus 6x1 squared x2 squared plus 4x1 x2 cubed plus x2 to the power 4. Okay, now I need some more space, so I'm going here. I express x1 to the power 4, x2 to the power 4. So x1 to the power 4 plus x2 to the power 4. Apologies for the handwriting, it's glitchy. Is going to be, now we take x1 x1 plus x2 to the power 4 minus, so minus this and this and this. Yeah, so we take these to the left. We take these to the other side. Minus 4 x1 cubed x2 minus 4 x1 x2 cubed and minus 6 x1 x2, well, x1 squared x2 squared. And then you do x1 plus x2 to the power 4. You simplify it, minus. Simplified. So here, these have a common factor, which is 4 x1 x2 x1 squared plus x2 squared minus 6 x1 x2 to the power 2. And look at that. Isn't that beautiful? x1 plus x2, we know it to be 7/3. So it's 7/3 to the power 4 minus 4 multiplied by x1, x2 is 1/3. Multiplied by 1/3, multiplied by this. So this is 43/9. We've established that. 43/9. You could do, I mean, Abhishek, what you're saying, but it's not easier. 6 multiplied by 1/3 squared, so multiplied by 1/9. And so 7 to the power 4, that's 49 times 49. That's 50 times 50, which is 2,500 minus 100, 2,400 plus 1, 2,401. 2,401. And you can applaud me if I am correct. Wow. Okay, I'm impressed with myself. 3 to the power 4 is 81. Okay, so 4 times 43, it's 172 over 3. So 172 over 27. And minus 6 over 9. So 6 over 9, I need it to be 81. So it's going to be 6 times 9, so 54. So 54. And here, instead of 27, I want 81. And I said 172, I want 3 times that. 3 times 172, 516. 516. And now what I do is 2,401 minus 516 minus 54 minus 1,830. No, 1,831. 31 over 81. Okay. So all our assignments are designed to be done without a calculator. You can use a calculator to check yourself, but you do need to show you're working. Okay. So now we're coming to problem 6, which is the trickiest, not the hardest, but the trickiest. Has anyone, so this is problem COMPOS. This is, let me open that. This is problem 15. Has anyone managed to do problem 15? Sorta. So, Ashrith, do you mind switching your mic and saying what are your thoughts on this problem? We can't hear you. It's I hear a fuzzing noise, but no voice. Ashrith, you found 2 roots, but no, I'm not asking you to find the roots. That's the thing. Jed, what about you? Can you switch on your mic and say what you think about it?
So you just find the values of a, b, and c here. So a is a squared plus 6a plus a, because that's what x squared is multiplied. And then do the same for b and c. So c is 14 plus a minus 3a squared. And then you put that into the discriminant. So you might want to like change a for a different variable like d, so you can use b squared minus 4ac and avoid getting the a's mixed up.
Okay.
And using that, you just expand out b squared minus ac, because you know when b squared minus ac is above 0, it's going to have 2 real roots. Hold on, I might have.
Okay, 2, but they're asking more than 2.
Mm-hmm.
2 values of a that solve it. 2 values of a that solve it. No, I mean, it's a perfectly valid method if I was asking to find x. If I said find x, that's what you do. Okay?
Yeah.
But I'm not asking for x, I'm asking for a. And I'm asking for which values of a does the equation have more than 2 distinct real roots. But what do you know about quadratic equations? Quadratic equations, so how many solutions do they have? Jed?
Well, if it's a quadratic, it can only have
There are
2
3
real
options. You can have
2 real roots, 1 real root, or no real roots.
no real roots. So more than 2 is not an option for a quadratic equation.
I see.
So where is the trick? So a quadratic equation can clearly not have 3 or more than 2 real roots. So the only possibility is that it's not a quadratic.
Okay, so if the value is when a equals
Sorry?
x, so what if you have a value of a when a is x? Because that would make it a
No,
cubic.
a is a constant value. A cannot be variable. A cannot depend on x. So but okay, let's look at a much simpler question. For which value of a does the equation have 1 solution? Or you know what? Yeah. Okay. Fair enough. For which values of a does the equation have one solution? Only one solution. Well, we know that this is a quadratic, and a quadratic has two solutions. If the discriminant is positive, it has one solution if the discriminant is 0, and it has 0 solutions if the discriminant is negative. So we find the discriminant. Discriminant is b squared, which is 16, minus 4ac, so minus 4 times minus 2 times a minus 1. Discriminant is b squared minus 4ac. This is the square rooted part of the formula, of the quadratic formula. So if the discriminant is positive, you have two roots. If the discriminant is 0, it is one root. And if the discriminant is negative, you have 0 roots. And the discriminant 16 minus plus 8a, so 16 plus 8a minus 8. So that is 8 plus 8a, so 8a plus 8. So it has one root when the discriminant is 0. So that means a equals minus 1. So when a equals minus 1, this equation has one root. Let's check that. So if a is minus 1, we have minus 2x squared minus 4x minus 2 equals 0, which simplifies to x squared plus 2x plus 1. And you can see that it has repeat roots. So if you find the roots, x1 equals minus 1, x2 equals minus 1 as well. So it has one root, minus 1. Now, Samuel, you said a equals 1. Was that a mistake, or do you have something to add to this? Very good. If a equals 1, the squared terms go away. So you have a linear. True, absolutely. Look, we assumed that this is a quadratic, and we used what we know about quadratics, but we didn't consider the fact that it is not a quadratic. When a equals 1, it's not a quadratic. If a equals 1, not a quadratic. A quadratic. So linear equation which has one solution. So linear. And indeed, you put that in. A equals 1, so it's minus 4x minus 2 equals 0. So x equals minus half. So one solution. So I want you to watch out for this, because there are some questions like this. So I really would like you to be very careful with this. Here is one solution. And here's one solution. So one solution. So the answer a equals minus 1, a equals 1. Okay, So do you think you understand where I'm leading you to? It has more than two distinct real roots. More than two distinct real roots. That simply means it is not a quadratic. A quadratic. And it's not a quadratic if this term is 0. And this term is 0 when a equals well, now you know how to solve quadratic equations in your head. It's going to be minus 4 and a equals minus 2. A equals minus 4 and a equals minus 2. Oh, sorry, I did not mean. Forget what I was talking about, because I'm about to give out the solution to the problem, which was not my intention. Okay. All right. So this is not a quadratic. So this must be 0, and a must be either. Well, there are two possibilities. A is and well, I don't want to spoil the fun. Yes, because exploring stuff is fun. So there are two possibilities, but you need to test them. You need to test both of them, because one of them will work and one of them won't. You need more than two, so it's quite a specific request. I'll give you another hint. So I'll leave this one to you. You have the fun. You have fun. Fun. More than two real roots. So that means not a quadratic. Not a quadratic. You have fun with this. I'll give you another hint, another simple question. For which values of a and b, the equation has more, the equation ax plus b equals 7 has more than one root. Well, this is a linear equation, and we know that linear equations have one root. And that's kind of true for all linear equations. Linear equations have one root. Well, how is it possible that they have more than one root? So in which case would it be multiplied by x? But that if you multiply this by x, this becomes a quadratic equation. You're kind of changing the original equation. Now, what about if I say, what if a is 0 and b is 7? Just out of the blue, I'm just saying, why not? Let's test. Let's check. Let's check. And this becomes 0x plus 7 equals 7. Or in other words, 0 equals 0. And this is an equation that has infinitely many solutions. Any x is a solution. And true, true for any x. So infinitely many solutions. Infinitely many solutions. Okay. So not one, but infinitely many roots. Two real distinct roots. It's not two, more than two. When we say two distinct roots, so for example, in this scenario, these are repeat roots. These are repeat roots. Repeat roots. And here, somewhere here, these are distinct roots. Distinct roots. Distinct roots. Okay, we've got 12 minutes left and we've got two problems. So solve the equation. So this is a rational equation. And in irrational equations, you always need to find the common denominator. Now, it looks as if that the common denominator is the product of all three. So common denominator, so is x squared minus 1 multiplied by x cubed plus 1 multiplied by x squared minus x plus 1. But that would lead to very, very hefty calculations. What you need to notice that x cubed plus 1 can be factorized as x plus 1, x squared minus x plus 1, which makes life easier. So from here, we got 30, x minus 1, x plus 1, plus 7 minus 18x. Sum of two cubes. It is, yeah, it is the sum of two cubes. Well done. And here you have x plus 1, x squared minus x plus 1 equals 13, x squared minus x plus 1. And you multiply this by x squared plus minus x plus 1. You multiply this by x minus 1. You multiply this by x minus 1, x plus 1. And that makes life much easier. So you get 30 x squared minus x plus 1 plus x minus 1, 7 minus 18x equals 13 x minus 1, x plus 1. Now, of course, there's a denominator, but it's the same thing. And it is acceptable to lose it. But a word of warning, you have to take into account that the denominator, that if you, for example, one of your solutions is x equals 1, and one of the denominators is, when x is 1, this is 0. So you need to understand that x is not equal to 1 and x is not equal to -1. Usually they write it out for you, but sometimes you need to do it yourself. In A levels, they mostly just write it out for you. But here, so you solve it, you get 30x squared minus 30x plus 30 plus 7x minus 18x squared. Yeah, the domain of the domain of the solutions. Absolutely. Well done. 7x minus 18x squared. The possible values of x. Yeah, the possible domain. 7x minus 18x squared minus 7 plus 18x equals, well, I mean, it's a quadratic equation. It's a quadratic equation, and I believe you know how to solve it. So 13x squared minus 13, so complete. And check that x is not equal to plus or minus 1. Okay, finally, we have this problem. This is sort of the factor theorem, given that x squared minus x minus 6 is a factor of that, find all roots of the equation. So if this is a factor, that means that that f of x can be written as x squared minus x minus 6 times something. So we need to find that something. So to do this, we use long division. Okay, if you're familiar with long division for polynomials, type 1. If you are not familiar with long division, please type 0. Okay, so about 50-50. Somebody put 2. Okay, so 50-50. So x to the power 4 minus 2x cubed minus 17x squared plus 18x plus 72 divided by x squared minus x minus 6. So this long division is not harder than just regular long division. So what you need to divide, you need to divide this polynomial by this polynomial. So you go x squared goes into x to the power 4, x squared times. So x to the power 4 divided by x squared is x squared. Now x squared times this is going to be x to the power 4 minus x to the power 3 minus 6x squared. You draw a line just like in regular division. You subtract, so 2 minus minus, so 4x to the power 4 minus x to the power 4 is 0. Minus 2x cubed minus x cubed is minus x cubed. Minus 17x squared minus 6x squared is minus 11x squared. And then we drop down the 18 plus 18x. So we divide that. So the minus x. So minus x cubed divided by x squared is minus x. So minus x cubed minus plus x squared plus 6x. We subtract minus 10x squared plus 12x plus 72. I don't like that. Oh no, it's okay. minus 12. Yes, yes, thank you. That makes more sense. That's what I didn't like. Yes, thank you. Minus 12. And so it's going to be minus 12. So minus 12x squared plus 12x plus 72 and 0. So that means that this expression can be written as x minus 6, x squared minus x minus 6 times x squared minus x minus 12. And we can factorize this further. Can we factorize this? The minus 3 plus 2, yeah, x minus 3 x plus 2. Does it work? It does. And this one is x minus, so minus 4 plus 3 minus 4x plus 3. So x1 is 3, x2 is minus 2, x3 is 4, and x4 is minus 3. So these are the solutions of the equation. I hope I didn't mess it up anyway. Okay, right. So this is hopefully this helps. Just let me know how useful you found the webinar. I don't know, on a scale of 1 to 5. All right, that's a scale 1 to 5. 5 out of 5. Right. Okay. If there's something you'd like, I'll have an anonymous feedback. So I'll send you a link into the chat so you can anonymously tell me what you would like to improve in the webinar. So no pressure, not like here. Question 6 was killing me. Yes, question 6 is tough. So every week, same time, every week at 6 o'clock. That's so we do physics, maths. Sometimes we do 2 physics in a row. Sometimes we'll do 2 maths in a row. That's yeah. You're welcome. You're welcome. I do hope it was useful. If you have any questions, I can stay for a few minutes. Otherwise, good luck.
Thank you.
Welcome.
Thank you very much, sir.
You're welcome.